Hello guys, today we are going to learn about water potential. First of all, we can see the meaning of water potential. What is water potential, or how do we define water potential? Water potential is the ability of water molecules to flow freely um, from one location to another location. So it's influenced by different factors, which we consider them our water potential components at the same time: metric potential, pressure potential, solid potential, and gravitational potential. Uh, this water potential is always negative, or the maximum it could be positive. It could be zero, because the solid particles would attract the molecules of water, which in turn limits their ability to move freely. Uh, it's because we add energy to get the water out of the solution. That's why it's referred as negative. So why are we, studying water potential? What is the significance? What is the importance to know water potential? This idea helps in the relation of water is capable of defying gravity and molecule moving freely. Uh, the capacity of water to move from one place to another uh, is it's important to explain the capacity of water from to moving from one location to another. Water potential also explains how water travels by osmosis, capillary action of the capillary rise of soil particles against gravity throughout the body of the plant. Uh, as you know, life would not exist without the continuous movement of water. For example, we can take photosynthesis. Photosynthesis is very critical for the plant to exist, and in turn, which is important for other living things as well. So plants can carry out photosynthesis due to the water. The food chain that are sustained by metabolism is also because of water potential. Uh, Biodiversity wouldn't exist without water potential, so it's very critical to know to explain water potential. So what are those components and the formula of water potential? The formula is water potential is equals to what the potential of solids, pressure potential, gravitational potential, and metric potential. So we can see them one by one. First, we can see solid potential. Solid potential is the potential of water created by solid in the solution. So when the solid's content increases in the solution, it limits the movement of water, the free movement of water. So it decreases the water potential. It reduces the water potential. So we say the solid potential of water is negative or less than zero all the time. Pressure potential, the second component of water potential, uh, it's the the hydrostatic pressure being applied to or pulled on the water. When it's applied to water, it's positive. When it's pulled on water, it become negative. There are different scenarios where we can say it's negative or positive. It increases the trigger pressure and makes the cell turgid. when we see this, we call it positive potential. uh, pressure potential Pressure potential became negative only when water goes from through the xylem from the roots of the plant part to the leaf part of the plant to the shoot part of the plant, because it needs energy to take the plant to the water molecule from the ground to the upper parts of the plant. There are also different examples for positive pressure potential. When you go below the surface of any groundwater or water table, it become positive. The turgor pressure in plants is positive potential. Blood pressure in animals, we can consider it a positive water potential. Here we have an example for a monocot plant uh, of different cells. The root part has, as you can see, has a maximum pressure potential. Then the epidermal cell follows with 0.5 pressure potential, and then the cortical cell, then per cell is the minimum, because it's towards the center of the plant cell. So pressure potential is mostly positive, but when the water molecule goes through xylem tissue from the root part to the shoot part of the plant, when that happens, it's negative potential. Otherwise, it's positive. Gravitational potential is also one of the components of water potential. It depends on the the reference level where we are. We call it negative or positive. If the water is above the reference level, the gravitational potential is positive. If we are below the reference level, it's considered to be a negative potential. It's negligible, and we don't consider it as far as water potential is concerned. We ignore most of the time gravitational potential. Matrix potential is the fourth and the last water potential component. It's due to the hydrogen bonding or adhesive intermolecular force of hydrogen bond or water with cells, soil particles, and other protoplasms. Uh, when this happens, matrix potential occurs. It's negative. What matrix potential is always negative value, has always negative value, and it's very little. It has very little effect on osmosis. That's why we also ignore matrix potential, as we ignore gravitational potential. So we ignore both gravitational and matrix potential. So water potential formula is water potential is equals to pressure solid potential plus pressure potential. That's what we consider water potential is the sum of two components, just solid potential, which is created by solids in the solution, and pressure potential, which is created by the pressure of the water in the cell or in the plant body, in the animal body. That's why we consider just of the components when we refer to water potential. This is what I have for today. If you like the video, you can subscribe my channel. I will see you in the next video. Thank you. Have a good one.